I am going to give a talk now on a new framework that we've created called EPF, short for Ember Persistence Foundation. And the tagline we're using is a framework for keeping your Ember.js in sync. And so, some people might ask me, Gordon, why the hell are you making another persistence framework for Ember.js? If you're familiar with the Ember.js landscape, there's already quite a few solutions out there. There's ember-data, ember-restless, ember-resource, ember-model, and now we have EPF. And I feel like we have a good reason for this, but first I'm going to talk a little bit about kind of our history with Ember and ember-data. We migrated a pretty big size Rails app to Ember and ember-data at the same time a couple years ago. We made our first PR in ember-data was made roughly 2 years ago. I checked GitHub, and we're not big contributors to ember-data, but we've made a few PRs. I kind of joke that if you use ember-data, you will be a contributor. There's just no way around it. And yeah, and we've been through essentially every single revision of ember-data from the time when there were no revisions up to about 3 months ago. And ember-data is actually a great framework. I know for a fact that all the dudes working on ember-data are a lot smarter than I am. And ember-data is good at a lot of things. It's really good at loading data. The serialization layer in ember-data is very good. It's very customizable. It's nice, good code. And side loading. Side loading just works. If you're using something like Rails with active model serializers in a mostly read-only app, side loading will just function. You can side load records with other records, and it will behave exactly the way you expect. And ember-data is also one of the first frameworks I've seen on the client to really tackle relationships in a meaningful way. You can have models who are related to other models and change those relationships and expect it to work. And I think this brings me to my last point on this slide is that we feel like ember-data really has the right level of abstraction. You look at the API when you're dealing with ember-data, it does feel right. It feels like dealing with models and relationships, and in this way is very nice and allows you to build a really cool application. But, you know, it doesn't always work perfectly. I mean, I hate ragging on ember-data, but some things for our applications use cases, which in our case, our application, I call it like a write-heavy CRUD application, where we not only just read a lot of data, but we also change a lot of data. And so there's a lot of concepts in ember-data. Like ember-data has a notion of transactions, which I feel like is kind of an overloaded term. There are no ACID guarantees. It's really, when you use ember-data, it's kind of just a way to group operations. And there's some peculiarities too, like transactions aren't promises. They break down on during errors, and you can't do complex transactions that involve multiple relationships between models. And another big point with ember-data that made it difficult for us to use is essentially when you're dealing with ember-data, data is locked when it's being saved on the server. So if you have a model, you change a property on the model, and you commit it to the server, while it's being passed to the server, you can't touch the model. If you do, it'll throw an error. And I think it's a perfectly valid application design to optimistically assume that your operations will succeed. I think it allows for a lot of nice UIs, and it shouldn't be something that the framework prevents. And then there are other things that gave us problems with ember-data, like error handling. 404 errors are difficult. A lot of corner cases. If you look at GitHub issues, you can see quite a few. And at the end of the day, we wound up living on a fork that had a lot of code on top of ember-data's master. It was hard to push that back in ember-data because new code would come in ember-data, which would conflict with our own code. And most people I talk to who use ember-data seriously also live on their own fork. And it's just kind of not a good place to be. We realized over time, having using ember-data for so long, that almost all of our issues with our application were from ember-data. I feel like Ember.js, its core, is extremely stable, especially right now. And it's a joy to use, but when it comes to ember-data, there are some cases, for our app's case, which is very write-heavy, which made it that we just realized we had to find something different. Like it just wasn't working for us. And we also explored other solutions. From the other slide, I think the solution we explored most in depth was Ember model. But really, when we take a step back, they're all very lightweight. And as I said before, like the level of abstraction that Ember.data gave felt right. It just wasn't quite there in terms of, for the reasons I said before. These other solutions just were missing features, like at the time, Ember model didn't have relationships, and the proper serialization layer, et cetera. And it just made it hard to migrate from Ember.data, which is our vote. And I think Ember.data is the preeminent data library right now. And we wanted to build something, or we wanted something where we could migrate from Ember.data with relative ease. And so we're kind of in this tough spot, where it's like, we really want something that works for us, but there really wasn't anything out there that really did. Like, we liked Ember.data, we needed that level of abstraction, like that's what we wanted as developers, and there just wasn't anything. So what we wound up doing is we decided to build a new persistence framework, and we called it EPF. And here I am today. So what's nice about building your own persistence framework is you can kind of take everything you've learned from using Ember.data and just dealing with a rich client app in general and kind of apply it to the framework you're building. So these are just some general observations we had when dealing with our application. The first thing is reading data is easy. I'm not speaking generally here, just for us, in our case, relative to integrating with the framework in terms of writing data, reading was pretty easy. I mean, if your app is something that has like big data problems or whatever, and this doesn't apply. But for us, we really were dealing with kind of a very much a CRUD write-heavy app, where we didn't have tens of thousands of models or anything like that. It was really just lots of models with relationships. And what was difficult for us was actually modifying the data. Like for instance, if you could imagine a graph of models, if you change various parts of that, it becomes very difficult from a framework perspective to make that just work the way you expect it to. And the other observation we had is to always expect new data. So you can kind of imagine like having a big socket attached to the back of your application that just keeps bringing updates in. I think that's very desirable, but data also comes from other places, like sideloading. You never know when another model can sideload a model which is being committed to the server and things will just break. So really with Ember.data's restriction on not allowing modifications while your model is being committed, it made loading new data at any point very difficult. So when we designed EPF, these are some of the main characteristics that we tried to build into it. The first one's non-blocking. This means that anytime you can always modify a model, no matter what. The model could be being saved, the model could be anything. The model could be part of a relationship that was removed. It'll always just work, and the framework won't break down, and it should be able to handle that. And EPF, it really focuses on synchronization rather than data loading. I think a lot of frameworks start from a loading perspective. They think, oh, we have a client and a server. The first thing we're going to do is come up with a way to load data from the server to the client. That becomes kind of the primitive that the framework's built around. EPF is built around synchronization. So what that means is, the way it thinks is the client has this graph of models on it. You can manipulate this graph of models in any way. You can delete models, modify relationships, and at the end of the day, the framework's job is to just synchronize that model graph with what's on the server. And part of this is dealing with correctness. I feel like if you look at some of the other frameworks, like the first thing they advertise is performance. For us, in my mind, performance doesn't mean much if at the end, if it's not correct. Like you're dealing with the data in your application. If it's not correct, performance is essentially moot. And we wanted a straightforward migration from Ember.data. And we also wanted to make some things nicer, like transactions, which we felt weren't quite the right abstraction. So EPF today, everything I'm about to show has been implemented. We use it in production at our company, GroupTalent. And we have, I think, roughly like 35 models that are all interrelated. they are, like I said, they're related. We change almost all of them on the clients, and we save them in all sorts of different ways, and it just works. But it's also a new framework, and it's not a perfect framework. There are definitely bugs, but for our uses, it has served us much better than ember-data. So now I'm just going to kind of walk through the API for APF. So the one thing I don't cover here is actually what is coming from the backend. So for all intents and purposes, this is almost identical to what you would expect from ember-data. It's just you're loading a model from an HTTP endpoint, and it's just JSON corresponding to that model. And relationships are just IDs, essentially. And yeah, so if you're using ember-data, it's essentially backend compatible. Like there are other things you can add to your backend for EPF to make some fancier things happen, but for all intents and purposes, you can just use your existing backend. So first things first, you don't, in ember-data, you declare a store. Here you can declare an adapter if you want, but you don't actually necessarily need to, only if you need to do things like maybe give your URLs a namespace. And when it comes to defining models, it's quite simple. From Dave's talk, he used ember-data in that talk, and they defined some of the properties almost exactly here. The exact same way as here. The only real difference is that there's an EP namespace instead of a DS namespace. So these are two models, and you could declare attributes using ep.adder, and you could declare relationships using ep.hasmeaning or belongs to. It's pretty intuitive. It's kind of what you expect from an ORM like active record or something of that nature. And so you can see here, this is actually, you see this session variable at the top. So the session is kind of the core interface to EPF in terms of loading and persisting data. And when you use EPF, this is kind of handled for you. You'll get a session in all of your controllers, all of your routes, and other places. So you can really just do this.get session. You'll have access to this session that you see here and in all of these other slides. So in order to load data, you can just do session.load, pass in the class name and an identifier, and this will return a promise, and it'll go to the server, return the JSON, populate a model, and you'll have your model. And you can also, instead of specifying a class name, you can specify a string. And this string it's kind of a string format that if you use other parts of Ember, might become more and more familiar over time. Instead of, I think in other frameworks, you pass in a string representation of the class. And in EPF, you pass in a string name, which is used to look up the model. But in reality, user just maps to app.user. And yeah, almost every part of the API in EPF uses promises. So in the last line, you can see session.load user.then, which is the JavaScript promise API. And you can, inside there, you know the user is loading. Creating models, very similar. You can create a model using session.create, pass in the model, give it attributes. After you're done creating a model, you can do something called set of flushing. And flushing is what basically takes the local changes on your client. Like I said before, that model graph, you have whatever is changed, flush will persist that to the server. So in this case, since we've created a model, session.flush will persist the model to the server, and it is a promise. Updating models, very similar. You just set new properties on the model. You can flush. The changes to persist on the server. What's interesting here is if you're using ember-data, instead of session.flush, it would be store.commit. But the line at the bottom, you wouldn't be able to do that until you knew that the commit has returned. But in EPF, you can always do that. And it's very smart enough to know when the data does come back from the server, it knows how to handle it so that the changes you've done since while the data was being sent to the server can be resolved against the changes that are coming from the server. And then relationships. You can create a model. You can set a a relationship on a model, much like you'd set an attribute. In this case, group has many users, and users belongs to group. In this case, you could just set the group on the user using just the normal set, and this also automatically updates inverse relationships. So on the second line, we set the belongs to the group, and then if you look at the group's users, it'll have that user because it automatically updates. And what's cool here is that you could really do all of this stuff. Like you can combine all of the slides I went through before, do whatever you want, and then at the end of the day, you can just do a session.flush, and it's smart enough to combine all of those operations into a single promise. And this, for instance, if you're using REST, this will mean that all of these different deletes, updates, changing relationship could potentially mean lots of different trips to the server, depending on how your API is structured. Maybe it could just mean one. But EPF is smart enough that it will just combine everything and order things correctly. So you can imagine if you're dealing with a relational backend, since the user belongs to a group, the user would have a group ID on it. And so if you're saving a new group and a new user in the same request, you want to save the group first so that the request for the user has a foreign key for the group. So it's just smart enough. You can just, what that really means is you can really just do whatever you want on the client and then just flush it, and it should work. And EPF also has ways to isolate changes. You can, like an example of this, when you're designing an application, so you might have a dialog where you edit a bunch of stuff, and the dialog has an OK and a cancel button. If in normal Ember land, if you're just dealing with, if your text inputs are just bound to your model, when it comes time to cancel, you need to do something fancy so that you know what the previous values were. In Ember.data, they have a notion of a transaction, and the transaction can roll back and set the data back. There's some issues with it, but it works pretty well. EPF does something similar, but it's a little bit different. So session is kind of all your models on your client. You can create a fork of all of those models, and it's called a child session. So if you do session.newSession, create a new session. And this new session, everything that's done to models from that new session is done in kind of a mirror universe from the original session, the main session that you're dealing with in the rest of your application. So you could imagine having a dialog which created all sorts of models, even created children with relationships and everything. And you could just do cancel on that dialog, and all of that just goes away. And to make that go away, it's as simple as just ignoring the fork. You have a child session, which is a fork of your session. If you don't want to actually persist those changes, just throw away the child session. But if you do want to persist those changes, you can just call child session.flush, which is similar. And what that does is it does persist them immediately to the parent session, and then also goes to the server. So it's kind of nice. Like this is when it comes to editing models, this is kind of the recommended way to do it. I think it makes a lot of sense to do things in kind of a safe environment before you actually commit them. And another point on this, like, it's one of the nice things about Ember is, you have the central source of truth. So you change a property somewhere, and it'll update everywhere in your application. Sometimes that's actually not desirable. Like for instance, if you're maybe editing your user, maybe you have a form that maybe changes your name, and you have like a header up in the header, you might not want that to change at the same time while you're typing. It can kind of be disruptive. And so features like this can actually enable those types of UIs very easily. And under the hood, what kind of makes all of this really happen is a method that you probably won't need to call manually, or in your day-to-day application development, but it's called merging. And so Session has a merge method, which basically does all the magic between resolving resolving new data with the data you've changed locally. So for instance, this is kind of the line on the top. It's just a basic jQuery AJAX call, just called getJSON, and that returns JSON. And with EPF, this is as simple as just taking the JSON that was returned from the server, setting the JSON attributes to a new model, and just merging that model into the session. And so under the hood, that's actually kind of what the REST adapter does in EPF. There's something very similar to that. And you can imagine maybe if, like I said before, always loading in data, you could imagine maybe having a socket connection, doing something like socket.io, and every time data comes in from the socket, you just merge the data in to your local session. And speaking of merging, this is kind of...
I'm sorry,
yeah.
Could you go over that slide step by step and sort of describe what the issue is and what your code is doing? Because this sounds like an important part. I'd like to understand how you deal with conflict.
Yeah, so actually that's what the next slides are dealing with.
Okay.
So really, just kind of, in this case, so we have a JSON call using AJAX with jQuery. This data, you could imagine just being essentially a JavaScript, a plain old JavaScript object that has the attributes for your model. You can just create a model, because for all intents and purposes, you can think of that as just a model that came from the server. So the server gave you a model. Now your client may or may not already have that model, and it may or may not have that model and have done local edits to that model. And so this merge method basically just says, here you go, client. Here's a model that's fresh copy from the server. Do what you will with it. And the merge method will go through cases like the client has never seen this model before. That's super easy. Let's just put it into the session. If the client has the model and it's done edits to it, then they'll do some fancier merge logic. And it even gets more advanced, like if it has the model but it's a different revision, then there can be some more complicated stuff. So I actually talk about a little bit more on how that works in the next couple slides.
So I'm jumping to conclusions, but session merge is a bunch of hooks where an application can override what it does to make it specific for that application.
Yes, exactly. So EPF has the notion of merge strategies. So by default, there are actually merge strategies that just handle this for you, where you could just be like, you know what, our application isn't mission critical. If there's a little bit of a conflict, we can just do like a per field. Like maybe you change the title, I change the text. Let's just put them together.
So session merge is kind of has a default, but it's really a wild card.
It has a default.
It's customizable.
Yeah, it's very customizable.
Okay.
Yep. So here's kind of just a little bit of a diagram. I think this is probably how a lot of just plain jQuery applications work. So you have a model on the client. Maybe you probably loaded that model previously from the server. You just, like I said before, get JSON. So you have a bunch of JSON. Maybe you have an Ember, or maybe it's in Ember land, maybe like an Ember object with some properties on it. You change those properties. You do a put request to the server. The server saves it in its database, responds saying OK, and then the OK could potentially have new data, and then you update your client. I feel like this is kind of a diagram of how like a lot of people would just do with jQuery, and perhaps like even some other applications as well. But it's a really simple process, and there's a lot of corner cases here. So what if updates are happening while the request is in transit? So say you update your client model, you send it to the server, and while the server is dealing with it, the client model, the user changes it more. The server sends back data, and this data could potentially be different. For instance, if you're trading a record, the server could add an ID, or maybe the server has a newer revision. And so now you have the local changes, which have some new edits since you sent it to the server. The server sends back a model with some new changes, and now you're kind of in a bind. You're kind of like, well, what do I do with this? I just have two models. I have no idea how their different properties are related, and there's nothing you can really do short of something simple, like either overriding the client's changes or just completely overriding the server's changes. But there's even worse scenarios, like say the server returns an error when you're saving the model. It's like a 412 error because your e-tag headers don't match. And your server's smart enough to be like, oh, you're trying to update a model that is out of date. So I'm not going to let you do that. Instead, I'm going to return a 412 and give you what the actual data is. And then you're in a really bad spot because you have a client version of the data that has changes in it against a version that was originally invalid, and you really don't know what to do. So the point I'm trying to make here is this kind of isn't sufficient for a lot of use cases. Like it'll work if you don't care that much in a lot of these scenarios. I think it's what a lot of applications do. Like I'd say most applications, even client-side applications, would just clobber the data. But because we're dealing with a rich client application, we actually have the luxury that because the client has state and can track a lot of things, you can actually do a lot better than this. Yeah, and I feel like this is also the reason why a lot of frameworks just lock the model, because that's easier than dealing with those cases. So in EPF, you can do something a little bit more complicated. And I don't think I'm going to walk through this entire thing because you probably want to. I don't even want to do that.
We have to trust you. That just works.
You have to. Yeah, you have to trust me. I'm not even sure it works, but I'm just kidding. I think it works. The net of it is that because the client has state, you can track lots of version history about when the client makes changes to a model. You store the original model it was making changes to. You can even store the original model just in case you get an even hairier situation. And because you have this extra data on the client, this kind of version history, you can do a lot fancier. You can do merging in a much more fancy way.
So this is client GitHub.
Yeah, it's very similar actually. It's like essentially that in a lot of ways. And so here you can imagine the server returns new data. You have client edits that are made on top of a different version. And here you have 3 models with a common ancestor. And you can do something like a 3-way merge. Or you can do something like whatever you wanted. You could pop up a dialog and tell the user there are 2 copies of the data that both change this field in this way. Which copy do you want to pick? So I think this is a much more elegant model than the diagram I showed you before. It's kind of, at its core, this is really what EPF is doing when I mean it's synchronizing changes and kind of enabling this non-blocking behavior. And this is just kind of another slide that the server returns an error code. You can reuse a previous copy to do the merging against because that's the proper ancestor for the 3-way merge, and things like that. There's actually quite a few cases like this, but I think this is an improvement. And really, as a user of EPF, you don't have to think about this graph. This graph isn't like something about, oh, what's going to happen if I do this? It's really just like, if you do get these corner cases, you can be like, oh, I'm using a merge strategy. That means that it keeps my local data, or whatever fields I've updated, it just keeps those, but keeps the new fields that come in. Or you can say it's a 3-way merge, so it'll just include both versions of the text interleaved, or whatever you'd like. And like I said before, because we're using a client that has state and is rich, you can do this. Like if you're just dealing with a web page, the server has to do all this because you just made a request to the server. The client loses all its state. I'm talking about just like a normal Rails app. The client loses all its state, and the server just says like, oh, this isn't valid. But you don't really have this richer version history that you can actually do a merge against. And so right now, everything I've shown you is built, but there is a roadmap. There's some low-hanging features. So as I said before, I said Ember.data is a great piece of software, and almost all, or a lot of EPS API is inspired by Ember.data, if not directly based. So there are some, I'd say right now, probably like 30% of the code is probably taken directly from Ember.data, especially things around the serialization and some of the inverse relationship updating. And Ember.data also has, so theoretically there's things like polymorphism that I get for free in the serialization layer that I just haven't tested yet and come through with a good story there, but There are some low-hanging features like polymorphism and a few just helper functions that I need to create that we don't use that haven't been a priority, but those are going to come soon. Some of them even have GitHub issues for them already opened. And there's some internal work I want to do. As I said before, performance isn't a big priority, but there are lots of things I could do to make it more performant. In our application, we don't really notice any performance issues with it, but it could be better. And collections. I really want to have a good story around collections. I think that a lot of people have issues with things like pagination. I know Ember.js users have issues with that, and we have our own home-rolled pagination solution that could be a lot better. I'd like to have collections and different types of collections that behave in different ways, be more of a first-class entity within EPF. And so I'd like to build something around that. And I'd like to have a socket adapter. Right now, especially because the main goal of this was to migrate from Ember.data to this, the main adapter is a REST adapter, so it focuses on REST APIs. But it's been designed for something like a socket adapter to be, built around it fairly easily. So I'd like to actually create one and support it. And then there needs to be a starter kit. And on this point, actually, it just came to my attention that Ray, who's in the audience right now, has created a project called Eps Skeleton, which looks, I haven't checked it out much, but it looks to be like the startings of a functional EPF application. It's kind of instructional in the sense that it shows you what you need to do to build. Do you want to?
Yeah, I was going to say, Ember-data example, if people know that, it's a parent-child nested relationship, and a lot of people use that to learn how to do that in Ember-data. And this has the similar functionality, but it's cleaner because your API is cleaner. So if people want to see side-by-side kind of what the learning curve is to go from that example to this, that's what it's about. So it's called Eps Skeleton. It's on GitHub.
Yeah, I'll put a link to it up on the meetup page later. So yeah, that's really cool. I looked at it; it has more commits than EPF itself. So.
Sorry, that's probably not an endorsement.
So yeah, so that's kind of the roadmap, and just kind of a long-term thing. I think they're kind of in like a pivotal moment right now where people are talking about like REST versus sockets. You know, there's crazy things like Meteor, which I can't remember what the protocol's called, like DDL or something. And then there's also the notion of transactional kind of applications versus real time. I mean, I remember Google Wave, when Google Wave first came out, it was completely real time. People would, as you type in a response, people could see the response being written. And people were like, oh, I can't do that. Like, I don't want to see people like have people see me correct my typing errors and things like that. So I think there is a level of granularity that applications need. Like, they don't always want every single thing that you do on your application to be updated in real time. So I actually do think there is a pretty big place for REST for a while, especially if the server is a lot more intelligent. But I also think sockets are very valuable for a lot of other reasons. And I think EPF is kind of in an interesting place where I would like to kind of be a framework where it could ultimately support both. I mean, naturally right now I really just want to make it so it really creates solid applications. But I think like the whole merging strategy, I think is kind of the kernel for something that could be a bit bigger. Some of the merging stuff was inspired by this dude at Google called Neil Fraser. I'm going to say his name. This is kind of an alternative to operational transform. So if you know what operational transform is, that's actually what I think Google Wave uses, and a lot of other frameworks use, like I think like Stippy or PyroPad, Ecopad, all those different. Share.js is a JavaScript implementation of operational transform. So this is kind of an alternative to it that uses more of a patching-based solution rather than capturing every single operation and transforming it. And I think there's enough parallels here that I think if I were to like just wave my hands, maybe someday I could come up with kind of a backend that would support EPF in a really nice way, or could support some really cool real-time stuff. But I mean, I'm not going to make any promises. It's just kind of like a long-term type thing. Because I think it is cool. Like real-time has its uses, and I can see really fancy adapters that have a backend component that kind of enables some really cool stuff. And so that's just kind of a hand-wavy long-term vision. And that's it, pretty much, for this. I think I finished quite a bit early, or 15 minutes early. But I really like, I don't want to rag on Ember.data. I think Ember.data is really good software, and they really did most of the hard work. I just kind of stole the good parts. And so I mean, like Tom Dale and Nico Katz and Stefan Penner are top of mind for me in terms of people who really put a lot of energy in Ember.data. And Ray I've been talking to Ray a lot. He's been kind of my guinea pig for testing some EPF stuff. And the Ember Auth guy actually has been opening a bunch of issues against EPF. So we'll see where that goes. But yeah, so that's kind of it in terms of the presentation. If anybody has any questions, totally, yeah.
Can you go over the flushing mechanism a little more?
Yeah.
Curious as to how many requests it actually makes in a given situation.
Yeah, so it kind of it depends on the situation. So there's also the notion of embedded models. So you could have like a has-many. You could imagine like a CouchDB style backend where like the documents have the relationships embedded in them. If that's the kind of backend you're dealing with, you could do a lot of stuff in one request. So it depends on the adapter, I guess my answer. But if we're just thinking in terms of a relational adapter, where every HTTP endpoint is just one model, currently it would make a request for every single model. I mean, it's easy to add bulk support. I'm actually going to add that soon. Where it'll just, if you have a bulk API endpoint, it'll just group them together and do them all at once. But in terms of relationships, you're limited there. Like if you have a parent and a child, if the child has a foreign key dependency on the parent, and you're creating them both, you kind of have to do that in two requests, because you need to save the parent, get the ID, and then once you have the ID, you populate that on the child, and then save the child. So you can imagine like this big tree of edits of like relationships, create dependencies between these models, and based on, you can kind of do like a topological type sort on all this whole graph of models, and kind of send it layer by layer to get to order the flush. So really at the end of everything, you're just changing a bunch of models, and you don't really care how many requests there are. I guess you do in terms of optimizing your application, but depending on your API, you can do any number of requests. Yeah?
So that's what you actually do. You actually do sort the...
Yeah. So I basically like, promises have a lot of cool stuff around that. So basically, it's just chaining a bunch of promises together in the correct order, and then once the promise returns, you populate the foreign key, and then just keep going through the promise tree. So.
It's just it doesn't lock, so it's the whole synchronization mechanism. The fact that it doesn't lock kind of makes that okay.
Well,
if you've got a lot of requests compared to, I mean, if you got.
Yeah, I mean, it's not like if you're doing a ton of requests, it's not like it's freezing your API.
Yeah,
it's not freezing your UI for that amount of time. It's actually, it can just happen in the background. But that said, there's probably something wrong if your application takes like minutes to complete like an update. And I actually had a pull request against Ember.data, that mechanism we were just talking about. I had a pull request against Ember.data that actually gave that functionality to their transactions. But in Ember.data, it's just hard. There's a lot of chefs in the kitchen here. Like, I had that pull request, and somebody else came in with another pull request that had something called per-type adapters, and it really didn't make sense for transactions to be promises, or like between adapter boundaries, and it's just kind of hard. So, anybody else stuff?
Can you talk about the client ID and when it's significant or not on either side, both the server side and the client side, and maybe explain what it is to people?
Sure. So in Ember.data, there's quite a few corner cases. So first and foremost, an existing API with Ember.data should work. If you use what the subset of Ember.data that would work against that API would work with EPF. But there's certain corner cases in Ember.data where you need another like a pass-through ID that goes from the client to the server. So for instance, if you have, say you have a parent that has many children, and it's embedded in that parent, when you save that child, so basically there's one request, it's the parent and all of his children. When you save those new children, you actually don't know if the server is sending back that same child that you saved, or maybe the server rejected that child, added a new child as the parent. And so you kind of need some mechanism to track, you need a mechanism to track that that is indeed the child that the client sent down, and that's the reason for the client ID. The reason why you could have just one ID if it was like a GUID that was generated on the client, but most backends, they have their own ID that the client can't synchronously create. So that's the reason for the client ID. But in reality, if you're using something like active model serializers, having a client ID just pass through from the client to the server and back is like one line of code to your active model serializers, your serializer logic. So it's not a big deal that you really have to think about. It's kind of just emulating this GUID that you want to have happen where the client can create IDs as well as the server. So, yeah.
Is this, how tied to Ember is this project? Can you use it with some other?
So, one of the nice things about Ember over something like Angular is the object model isn't really tied to like the template and the view layer. So a lot of stuff in this, like updating inverse relationships, kind of relies on the Ember object model. But beyond that, and it really relies on getters and setters. So if you want, because like the way you do dirty tracking and things like that, you rely on setting a property on a model and being able to have a getter which actually intercepts that property change. So I mean, it kind of relies in that regard, but really this could be done in a different framework. Like it's not super Ember model or Ember specific. It would be kind of nice to put this into like a more generic library that could be used outside of it, actually, if I could. Who knows? So I think he was first.
Yeah. So just about the merge synchronization, you have conflicts between the server and the client. I saw there was a callback on the flush. So when that flush completes, is that when you would enter into this kind of?
No. So the flush will complete after the merging is done. So if you wanted to kind of intercept the merge, you create a merge strategy that you can kind of like register a merge strategy with your session, and that will kind of dictate how the merging is done. And you could do something custom in there if you wanted to like display a dialog to the user. But in terms of the callback for the flush, you just assume everything up until that point is good, and it's all copacetic. So yeah, there'd be a different hook for doing like what you're describing.
Okay, so it's like a merge strategy that's like a rules.
Yeah, so you can think of like different merge things, different ways of merging stuff, like a three-way merge, or maybe just keeping theirs and tossing yours out, or maybe keeping both and popping a dialog up to the user, or yeah. So I hope that answered your question. Did you have a question?
Yeah. What databases, I don't know if you're using the same approach that ember-data is using, but what databases does EPF support? Do you have an adapter for each type of database, or how does that work?
So it's actually kind of keeping the adapter backend agnostic. Something Ember.data tried to do is also something that EPF does. So I think that it supports, if not almost supports, something like Mongo or Couch, where foreign keys are kind of, it's common practice for documents to be usually embedded, or for instance, a has-many, the owner of the has-many, or the parent of the has-many would be the one who updates the foreign keys. That's almost there. So the goal is to have it be adapter backend agnostic, which is it's a big goal. So like I said, the framework's not perfect, so I would.
So if I use Couch, can I use EPF today?
I think you could, especially if you just use a lot of embedded stuff. In terms of, you might run into a couple bugs, but I think it's like almost there for that.
What database do you use with it?
We use a relational database, so we actually use MySQL. Prefer Postgres, but we're using MySQL.
Have you done some test with embedded objects?
With what objects?
Embedded objects.
We use embedded objects all over the place. We actually, embedded objects are one nice way to put complex changes into a single HTTP request. So we definitely use embedded objects, mostly remnants from ember-data days, because that's how we kind of got around ember-data, dealing with relationships. At ember-data, if you have a single transaction and you create a parent and a child, you can't just do that in a transaction. You have to like create the parent and then create the child with the parent saved. But sometimes you want that to be, sometimes you want that to work, and so we can just kind of hack around that with an embedded relationship in ember-data. So, okay.
Thanks.
Cool. Thanks for listening. And epf.io, you want to
How much, and how much have Tom Dale and Yehuda Cat seen of this? I mean, have
they haven't
floated
really,
it to them yet? Or?
they haven't really commented on it. Like there was a while where I was trying to contribute a lot to ember-data, like a brief period before I kind of gave up. But I told Tom that I was going off and doing this, and he was like, cool. And I think a lot of the people who worked on ember-data kind of knew I was doing this.
There was a tweet today, someone said like, Ember-data, Ember model, EPF, and there's another one too. I can't remember what it was called, but someone said like, can't we all just get along?
I mean, I would like that. Like, I'm not trying to create an island here where, I mean, I would like to have, I wish this were ember-data.
You're like the MERB of Rails.
Kind of, yeah. It's hard to create.
It's hard, not quite that, because they're not against people. I mean, ember-data is alpha. I had big ambitions, but I think time has been short, and so they want people making solutions that work for people.
Yeah.
The problem with so a lot of frameworks just say, well, we'll put a little dressing on Ajax, but you really need to cache the data that's coming back. Otherwise, you're going to be super chatty the server, and once you cache it, you're responsible for syncing it. So as soon as there isn't any way around not dealing with syncing and updating an identity map with a long-lived client-side application. So stuff like an Angular or Backbone, where they do a little dressing on Ajax and say this is our persistence layer, they were not fond of that. So
Yeah.
it's caused a bit of like pain in that people say, well, you don't have a data story.
Yeah,
But those other things, they don't have a data story either.
yeah.
The Meteor, the one you mentioned, is just less right wins.
Yeah, a lot of
Socket
people.
streams back data, and whatever comes back just clobbers.
Yeah, a big misconception I feel like people have about Meteor.js is that it uses something fancy like operational transform. Like in reality, you're using Meteor, the updates are live, but if you have two users simultaneously typing in two text editors or two text fields that correspond to the same piece of data, they'll be overwriting each other. So it's not really like, it's not super fancy, but I know they have I think they have a guy who wrote Share.js, which is an operational transform library. Maybe, I don't know, I'm not going to know this for certain, but I think they'll probably go in that direction, or they might already have, but yeah, that is an interesting thing.
So I mean, it's not non-trivial, and so I mean, there's been a little bit of a problem with the reputation of saying this is alpha and not doing something like a little bit more glorified Ajax. But
I think just building a framework up, starting from glorifying Ajax, I think is the wrong approach. Like, I don't even like calling things, because you think about loading, and then at the end of the day, when it comes to hacking on like complex mutations of the data, it's hard to build that on top of a
It's
framework
good
that's built
for
on
read-only.
Yeah, if you're using read-only, if your application's mostly read-only, which I feel like a lot of applications are.
Just pull it and
Well,
you cache it, and
yeah.
then you're good. But that doesn't.
Like, I don't even really like the term identity map. Like, I feel like it's good for like read-only heavy applications, but in my mind, EPF has its own graph of models on the client, and that serves as what a lot of firms call an identity map. An identity map is just a cache that just like takes stuff from the server and just saves it and saves it. That's pretty much it. Like, in my mind, it's really just a graph of models on the client, and that's kind of how I think about it. Like, I don't think about it some cache that expires. I think of more of like a graph of models that you can refresh whenever you want, or new data can come in to update the graphic models. Yep.
Could you explain why you have the extra backup of the data and not just the old and the new? Why
Yeah,
the
so
third one?
So actually, I think, so like for instance, say this is a, say you're saving data and you, the server retains, so say the server returns a failure, and that failure doesn't include new data. So the server's just like 500, whatever, like you're kind of screwed. Whatever changes have happened to the model since you flushed to the server, you need to kind of, logically those changes need to correspond to the version of the data before the server errored. So when you actually do get a model back from the server, you have the right ancestor to do the merging against. So this is kind of just to deal with cases where you know that the operation has failed and the thing you think is the server representation isn't the server representation. So, yeah, but in a lot of cases, it won't be used, but it's just in case.
So which of those datas would be the one that the server sent back if it sent you your data's old?
So,
The middle one?
so in the case where the server actually sends back, so
there's actually four.
This is actually a case. So so I'll kind of walk you through this. This is actually that exact case. So like a 412, if you use like something like e-tags, a 412 is what your server should respond with. If the header match fails, so it'll say like, hey, you're trying to update something and you're not dealing with the latest data, so I'm going to say you can't. And it'll return an error. And the error could contain the latest data, so you have the latest data. And so in this case, and say your client model over here, so this is just the data that the server just gave you from this request, right here.
Oh, the client shadow is what I sent to the server.
Yeah.
The client model is the one, I'm the only one who has that. That's the latest and greatest.
Yeah, that's like, I haven't committed this yet. But
And the shadow backup is the original model I most recently got from the server.
Yeah.
So I know that that's, oh, okay, now,
Yeah.
okay, I see that.
Yeah, I think
But you might want to explain it.
Yeah.
If other people want to know.
Yeah, so that's,
server model.
So
Yeah.
you should explain that though, because that's a good diagram. And it'll help people understand what problems you're tackling. And how
yeah,
that's
totally.
useful.
So basically, here is a model. So this is like the latest model. So this is the model the user is actively manipulating. Maybe, whatever. And you can, when you want to save this model, and then you also have another model actually, which is the last known data that the client got from the server. So when you perform a flush, it actually diffs the latest and greatest versus the last known from the server. And so it does this diff, like you think you could just be like, oh, it's dirty, let's just flush it. But it's kind of tricky to know, like, what if you change a model, and then you change it back to what it was on the server? So in that case, it wouldn't be dirty. So we do this diff. So you have the latest and greatest, and the last from the server. You diff it, and if they're different, you know there's a change that needs to be made. And you create edits from that change, and that gets sent to the server. And while that's happening too, you take that last known data that you got from the server, and you copy it over to the backup. And then you take the latest and greatest that you were working on, and you set it to the version that the server has, the version that you sent to the, and then you set it, you overwrite.
Your optimistic is going
Yeah.
to be the...
Yeah, because you're optimistic. I just sent this diff to the server, so I'm optimistic that this is the representation the server is going to have. But the actual representation, the last known that I got from the server, I save this backup.
Okay.
And so then it goes to the server, and the server comes. I'll do the other one first. Goes to the server says, okay, great, and returns another model. And this model actually could have changes as well. The server could be like, okay, great, but I've changed this property to this, or something like that. So this is actually still new data. And then so you have, so right here you have what? Yeah, and then you have the server model, and then you perform the merge against what the client thinks it's working against, the diff that the server sent on top of what the client is working against, and then the client itself. And that merge can be whatever you do. But in the case of an error, the server didn't get this. Your optimistic assumption that the server was going to get this data isn't correct. And so you have to do it through a merge against this shadow backup, because that is the true ancestor.
And then you throw away the client shadow?
Yeah, so after this process, like you can probably, like once it merges, in this error case, when you're using this as the ancestor, merging these three, you probably copy the shadow back to what the client's working off of.
So it's pretty complicated. You can get updates from the client, or you can get updates from the server, and they can both be updating at the same time.
Yep.
But your technique here handles all of the basic cases.
Yeah.
And-
I mean, this is
and you would
emergency, like it's not perfect. I mean, you can still get yourself in hairy situations and crazy stuff's happening, but I think this is a big improvement over
The simplistic model.
this. Like it's really, I feel like this, and this is what people do with jQuery, what I've seen. And I think most people probably don't even use Z tags, so you just clobber everything. So really, it's like I think it's a big improvement over this model right here.
So you could see a socket.io coming in. If you go back to the other example, a socket.io, a stream could be coming in the side.
Yeah,
as well?
that's the goal. Like, you could change the socket. You could replace the socket.io with maybe just like a set timeout and a model refresh, or like whatever. One of the designs is to have the assumption on the framework level that data could come in at any point in time, and you have no control over that. It could be side loading, it could be from the socket, it could be from just a pending request, or just maybe a manual call to session.merge. And the goal here is to handle all these cases.
I like that goal.
Yeah, I mean, I kind of, I hope this model works. I mean, it's working for us right now, but we want to make our application a little bit more frequently updating. So I think one of the next things we're going to add is the socket adapter and release MVPF and actually have it do this type of stuff.
Thank you.
Okay.
Yeah.
Cool.